Okay, so welcome on in. We are going to continue off of what we started on, what was it, Wednesday. Um, Basically, on Wednesday, we did a review of Boolean expressions and conditionals, which we saw was a way of making a decision in our program code. Today, we're going to move on to our new material, which is covered in Code HS's section 3.5, something called compound Boolean expressions, where your decision is going to require more than one step. So there's actually a way of doing this type of decision making in your program without using compound Boolean expressions, but we're going to see why it's really good to have compound Boolean expression. It really makes our code easier to read and manage. So let's think about a scenario where our decision requires more than one step, one or more conditional. Okay, so we've got this question: can I adopt a cat? And I know that I can adopt a cat if I have exactly $40. I need exact change. And I'm over the age of 14. So I have to be 15 or older. So last time we looked at a way of representing conditionals and decision making with something called a flowchart. And we're going to do that again. So here is a flowchart that you'll notice you have to evaluate one thing, one conditional, and if that conditional is true, there's another conditional that we have to evaluate before we make our decision of whether or not we can adopt the cat. So if we take a look at this, we're going to say that our money is $39. So we can see that our money variable has been assigned the value 39. And then our age in this scenario is 17. So our age variable has been assigned the value 17. So now we want to move down here and actually evaluate our Boolean expressions. So the first thing we're going to evaluate is the truth of this statement. Age is greater than 14. So to do that, first we need to look inside of age and see what that value is and bring it on down. So that's 17. So 17 is in fact greater than 14. So we know that this particular Boolean expression is going to evaluate to true. So now we know that we can move down to this true branch. So once we do that, we see that we have to evaluate another Boolean expression. We have to evaluate whether or not our money is exactly $40. And so to do that, we have to bring down our money value. So we see that we have 39, we'll bring that down. And 39 is not exactly 49, 39 is not exactly 40. So we're gonna branch to the false side here. So we're gonna go ahead and branch and then ultimately decide, yeah, I cannot adopt a cat, sadly. So this looks kind of, maybe it's a little easy to follow once you have it, laid out in a flowchart like this. But I'm going to show you how quickly this might look a little confusing in code. So let's go ahead and I'm going to open up a replit thing and actually implement the same idea in Java code. So we know that the question is, can I adopt a cat? And I know that I can adopt a cat if, let's see, what was the requirements? I am older than 14. And I'm going to put that on its own line. And I have exactly $40. Okay, so that's our scenario. So let's go ahead and convert that to Java code. So we're just going to go ahead and start off with, rather than using scanner to enter in our age and money, I'll just set those as variables. So let's use the same values that they had in our example here. So we've got an age of 17, and we have money as $39. We have $39. Whoops. Okay, so now we can actually look at how we can implement the conditionals. So I'm going to look at the first conditional. First conditional is I am older than 14, which we can see here. We would just write if age greater than 14. So let's go ahead and do that. So if age is greater than 14, what are we going to do? Well, we know that we don't know yet if we can adopt the cat if that's true, because we know we have to also evaluate if we have enough money. But we do know that if this is false, that we can't adopt a cat. So I'm going to go ahead and in my else branch, I'm going to print out that I can't adopt a cat. Can't adopt a cat. Okay. So yeah, going back up to the if branch here, I know that if this is true, I need to evaluate yet another condition to see if I can adopt a cat. And so let's look at what that is. Money has to be exactly 40. So I'm going to write as my as a nested conditional, a nested if statement, if money is equal to 40. So when I mean nested, it means it's going to be inside of this if. Remember, I'm only going to get to this code if this first conditional is true. So now I'm going to see if money is equal to 40. If that is true, I know that both of these two conditionals is true, and that's the scenario where I can indeed adopt a cat. I can adopt a cat. I do have to put another else here, because if this is false, I want to say that I can't adopt a cat. And that's because I'm not going to get to this else if I already did this, if I was already in this if. Remember that I only get to this else if this first if is false. So I need to actually duplicate some code here. I need to actually have another print statement that states that I can't adopt a cat. And that's in the scenario where I'm old enough, but I don't have enough money. So I need to be able to do that. So you can see how this can quickly get messy. There's duplicated code. So here's where we are really going to learn why compound conditional statements kind of helps us out in making our code more readable, less repetitive. Okay, so I'll keep that there, and let's go ahead and take a look at how to create compound Boolean expressions. The way we're going to create these is by introducing logical operators. So logical operators are ways of creating, it enables us to create compound expressions. Just like in English class, if you've learned about your compound conjunctions, they're similar, right? You have and, so you can link two different sentences together. So in coding, you actually have more logical operators than this, but we only have to worry about these three. And they are and, or, and not. You'll see on the right here that they're written in plain English. You'll see this in pseudocode. And in some languages, it actually uses, like Python will actually use the word and stuff like that. In Java and other languages, you'll see these symbols here. So you have the double ampersand for and then these characters are called pipes. So this is the double pipe, which means or. And if you're trying to see how you would actually type this, look at your keyboard and find the enter or the return key on the kind of on the right hand side there. And right above it will be a key that you'll hold, that you'll press down while holding shift, and then you should be able to make the pipe. So yeah, double pipe is or. And then the last one is an exclamation mark. Whenever you see an exclamation mark, that means not. Okay, so we're going to be talking a little bit about what these operators do in the next few slides. All right, so we're going to take a look at what's called the truth tables for each of these three logical operators. We're going to kind of stick with the sticky note representation of Boolean values. They're still going to be blue, but to kind of make it a little visually easier to look at, I'm going to be using dark blue stickies for true and a light blue for false. So let's take a look at the truth table for and. So here's and. Remember, these operators are used to join two or more Boolean expressions. So you'll notice that on the left and the right hand side of the and, you'll have Boolean values. Okay, so true and true is one example that we could have, and that would evaluate to true. You'll notice that you have all four different combinations that you could have. So you have true and true, true and false, false and true, false and false. So what I would like you to do is take a look at this table. I want you to focus on finding a pattern. So look at the left-hand side. And then compare to what's going on the right-hand side. So on the left-hand side, you have the actual compound expression. On the right-hand side is what that compound expression evaluates to. I want you to try to see if you can see a pattern that that is visible to you. So the statement true and true evaluates to true. The statement true and false evaluates to false. False and true evaluates to false, and false evaluates to false. Do you see a pattern? And if you see a pattern, if you think you see a pattern, tell me what it is in the chat. Give you a moment to look that over. All right, what do y'all think? Do you see a pattern that arises here? So notice that you only have one expression that evaluates to true. How is that? How is this expression unique from the rest of these? What do you notice? Yes, exactly. It doesn't have any falses. For the and symbol, if you have just one false, the whole thing becomes false. So in order to have a true and statement, both sides must be true. That is the big idea about and. So that gets summarized right here. So both must be true for this type of Boolean expression using and to evaluate as true. If there's even just one false, it negates the entire thing. Okay, so please let me know if you have any questions about that. Make sure you can either hop on the microphone or message me in chat. Let's take a look at the next one, which is or. And or is going to wind up being a bit different. Okay, so let's take a look at this. So again, same thing. Look at the truth table for or, and what do you notice? What's the pattern here? What differences do you notice, and what can you explain about that difference? Yeah, so if there is even just one true, in this case, the whole thing becomes true. The only way you're going to get a false with an or is if both sides are false. So that's the big idea to see here for our or operator. So again, if there's just one true in an or statement, the whole thing evaluates to true. The next one is not, and not is a lot easier because there's really just two entries in the truth table. You have two Boolean values, and it really just takes the opposite of what the Boolean value is. It's like a light switch kind of. It toggles it from true and false. So not true is going to turn it to the opposite, which is false. And not false is going to turn it to the opposite of false, which is true. Okay, so it just takes the opposite Boolean value. So now we can take a look at how we can use our logical operator and to make that code that can determine if I can adopt a cat better. It'll make it a lot easier to read because we can then join together two conditional statements with logical and. So let's take a look at what the flowchart would look like first. So you'll notice the major difference here is that you don't have multiple layers of branching, right? You can see here that we have just one conditional to evaluate. And we do see that both conditions are being linked together with a logical and here. Okay, so in this scenario, I think they're giving us some different values here. So in this scenario, let's say my money is $40 and my age is 15. So we're going to kind of do the same process where we bring those values down where we see the variable names. So money is going to get 40, age is going to get 15. So let's bring those down. And now we can evaluate this statement. So first we're going to evaluate this side has a Boolean expression. So the left-hand side of the and has a Boolean expression. Let's evaluate that first. Is 40 equal to 40? Yeah, 40 is the same thing as 40. So this side's going to be true. And then we'll look at the right-hand side of our and we're asking, is 15 bigger than 14? Yeah, that's also true. So let's go ahead and say true and true. So what does true and true evaluate to? What does that wind up being? True and true. Yes, it winds up being true. So if you look at the truth table, or we just kind of memorize it and understand it, we know that that's going to evaluate to true. And so we're going to wind up branching to the true side and saying that, yes, indeed, we can adopt a cat. So now we can take a look at how we can apply this new idea, this new compound Boolean expression, to our code. So let's take a look at what that expression was again. So we're going to go back to our code. And instead of this huge mess here where we have nested if statements, we're going to get rid of that nested guy right there. And we're going to modify this truth statement right here. So instead of just checking to see if my age is greater than 14, I'm going to add my logical and then I'm going to put that second conditional on the right-hand side. I'm going to check to see if money is equal to 40. Okay. And if this is true, I know that I can adopt a cat. So I'm going to go ahead and put that print statement right there. I can adopt a cat. So let's go ahead and run it with the values of 17 and 39, which we already know will wind up as false because money has to be exactly 40. So this should print out that I can not adopt a cat. It should go to the else. Okay, so now let's use values that will be true. So let's make money be exactly 40. 17 we know will result in a true here because 17 is bigger than 14. And then money will be 40, which is exactly 40. So now we should get the result that I can adopt a cat. Awesome. And again, just notice how much easier this is to read just by adding logical and being able to join those two conditions together. So that's a great skill to have. Phoenix agrees. Okay, so here are our key takeaways for this. A Boolean value is a data type that's either true or false. We went over the comparison operators. We went over how to reduce Boolean expressions to a single value, and how we can compare single values and those single values like here, and evaluate that to a true or a false. We also today introduced logical operators and, or, and not. There's a mistake on this slide. That should not be there, just the exclamation mark. Both sides of the logical operator also are reduced to a single Boolean value, so you can see that here. And then the entire compound Boolean expression then evaluates to a single Boolean value. And if you're confused about reducing compound Booleans, make sure you take another look at those truth tables. I'm going to be uploading this video after class. You'll see them there. You can also Google truth tables for and, or, and not. Ask me questions and things like that. Okay, so to end class today, we're just going to actually look at, we're going to take a look at one example on CodeHS. There we go. Okay, so we're going to take a look at the light switch example. The light switch example is going to show us an example that has logical not. And if you remember, logical not simply takes the opposite of whatever Boolean value you have. So let's take a look. That we can see on line 9, we have a variable called light on, which is a Boolean variable. So let's go ahead and kind of draw our model here. So this is called light on, and it is initialized to the value of true. So we're going to write true in there. On line 10, it's going to print out light on question mark and then the truth value of light on. So at this point, it's true, so it's going to print out true. What happens on line 11? Let me know, what do you think is going to happen on line 11? It says light on gets not light on. What will that do? What's that gonna do? It's gonna make it false, right? It's gonna take the opposite of what it is. Right now it's true. The opposite of true is false. So it's gonna erase that true and it's gonna replace it with a false. So when it gets printed out again on line 12, we're going to see false. And then what happens on line 13? It's going to toggle it back to true, right? It says light on gets not light on. So that means it's going to take the opposite of what it currently is, which is false, and the opposite of false is true. So we're going to replace that with true. So that when we get to line 14, it's going to print out true again. So let's go ahead and check that. So what I said is it will print out true, false, and then true again. So let's check to see if that is a correct prediction here. So yes, we have true, false, and then true. So, so far we have looked at examples that use the AND operator, logical and we've just taken a look at use of logical not. Next class on Monday, we will take a look at the rest of the examples here that also include usages of or. And we'll probably, because there's only 2 examples, we'll probably be able to start on the exercises together. I'm not going to assign you homework over the weekend because I don't believe in that. But if you want to take a look at it and preview it, if you have time and you want to do that, that's awesome. So again, this is 3.5. So if you want to preview it over the weekend, go for it, but I'm not assigning anything. And that about wraps things up. So let me know if you have any questions. I will stick around in case you do. But I hope everyone has a great weekend, and I'll see you all on Monday.